All right, so welcome to module 1.3. So in the previous module, we mentioned that other than buffer overflow, we have integer overflow and we have format string vulnerability, and we have other things like memory allocation, deallocation related problems that can be exploited. But in this module, it's another small module. Here we'll talk about the format string vulnerability. Now this is also very common vulnerability, and this is something that you will also be exploiting in your projects, so you will learn it better. So we'll talk some examples of format string vulnerabilities. So here is an example. So first of all, before we go into this example, remember that printf, scanf, and similar sprintf, fprintf, and so on, these programs use what is called a format string. So if we use %d, we mean integer. If we use %x, we mean hex. If we use %s, we mean a string. If we use %c, we mean a character. So these are the formatting instructions given by format string. So when we say, when we do printf, we normally give a format string so that it is printed in the right format. So there are other obscure ones, for example, %n. So what %n does is that wherever you put %n, it has the value of the number of characters written thus far, right? So for example, in this printf, it says the number of bytes written up to this point x %n, then it will count the number of bytes written until this point, and here that value will be shown. So for example, count1 is the variable onto which this %n refers to, and then count2 is the variable onto which this %n value will be correspondingly put in. So in this contrived example, you have this 4 variables a, b, and count1, count2, and I am having a printf with %n in 2 places. In the first place, it's basically a number of characters written unto this point, so count1 will be counting the number of characters up to this point, and count2 will be counting the number of characters written until this point. And so then that's all fine. Then you can print those numbers using proper regular printf. And then if you want, you can also do like print the values of a and b and address of a and things like that. So let's see what happens when we execute this program. So first of all, until this point you can manually count. There are 46 characters written until this point, and until this point there are 113 characters written, so which is all fine. And here when I print this one, it says a is %d, so a is 5 because that's what we did here, and then it gives the address of a, and this will get differently in your system probably, and then b is 7. So this program is working fine. So let's see what happens if we make some change. So here everything is same as before here, but here instead of a ampersand a and b, I just put a ampersand a and nothing else, and b, although I have 3 formatting instructions here, %d here, %08x here, and %x here, but I have 2 corresponding matching variables. So let's see what happens here. So it says a is 5, address of a is this, but then for b it is printing something. Now what is this something? This something is actually the address of a. Now why is it printing address of a again? Now remember that this printf function has 2 inputs, right? So when it has 2 inputs, so let's see the stack frame when this printf is called from the main. So this stack frame, remember the stack grows from top to bottom, and the inputs are in the reverse order. So this will be the arguments of this function, and a, and then a, and then the string whatever, and so on. And then when you had a B here, so that B would be here. So now what is happening is that this printf has 3 inputs according to this formatting instruction, but it's getting if you take out this part, the B part, and just keep the other parts up to A, ampersand A, and so on, then when it tries to match, it will go to the next address because it expects its inputs to be in the reverse order. So for B, it will actually take whatever was here, and therefore it basically got it's actually not the address of A, it's actually the content of whatever is here, and that whatever is actually the stack frame's previous stack's previous stack frame. So whatever value is there is printed. Now what is wrong with this is that instead of printing B, because of a mistake by the programmer, it is printing the content of your program stack from the caller's stack frame, which compromises much information. Like, so if I am trying to actually see the content of the stack, I could actually do this trick as an exploit and figure out what are the content of the stack, and then use that to do the buffer overflow attack later. So that's the problem. So here is another example, and in this example I have this program called which we'll call format vuln, and then I am just having this input which is being then string copied onto text, and then when you do that, you are going to print whatever goes into text. Now note that while executing this program, I have used a string as my argument, in which I have a string formatting instruction. So now what will happen is that if I am not careful, then the printf will treat this as a formatting instruction. So in the first example, I am saying printf %s text. In that case, everything will be fine, and we can because this text will be now interpreted as a string. So %x will come out as part of the string. But in the second case, I am saying printf text without using %s or any formatting instruction. Therefore, printf will treat this %x as a formatting instruction, and therefore it will actually create problems. So in this case, if you call this function program with this argument, so you are basically creating a string which has a address formatting followed by times 40. So it will basically try to print the addresses of 40 consecutive locations, and therefore it will compromise a lot of information about your program stack, because it will, as in the previous example, it will go back into the stack frame of the caller and try start outputting those. So in case of format string, major issue is that if the before passing something onto this if printf, if we are not checking the sanity of your input. So for example, in this function, I am trying to print onto standard error the string that will come with user variable. Now this user variable may be assigned a formatting string, and in that case, either the program will crash, which will be a denial of service attack, or the program will print memory contents, which is also a problem. So correct form would be that if you want to print this string associated with this variable, then you must put your own formatting instruction, so that if there are characters looking like formatting instruction in the string that is being passed, they are not interpreted as string formatting instructions. So this is a common mistake done by many programmers, and it has been found happening in real systems. So there are many functions that are vulnerable to this format string vulnerability, like printf, fprintf, sprintf, vprintf, and so on. Many logging functions like syslog, error log, warning, all these things actually require formatting instructions and therefore are subject to this kind of vulnerability. So the main exploits that happen with string formatting vulnerability are mostly about trying to figure out what's in your memory, what's into the stack. So you can walk up stack until desired pointer is found. So this is something that you can do, or writing to arbitrary memory. So for example, in this one, your temp is actually a memory location onto which 6 will be written, and therefore you can write onto this percentage n will basically be the number of characters written, and this would be actually your addresses. So because of this cryptic nature of printf, scanf, and so on, this kind of mistakes often occur, and therefore you have to be careful about them. And as you try more and more examples, you will find this actually are quite you can be quite innovative and use this to do various kinds of tricks to discover points at which you can actually do exploits. So the next module will be talking about defenses. So this ends module 1.3, and next module will be about defenses.